IDE disk. That thing runs right around what, about $1,700–1,800?
Yeah.
Somewhere in that ballpark. If you go to what I consider to be an enterprise class version of that, now you've purchased the X330, and basically you've added about $1,000 to the cost of the system. But now you've gained hot swap disks. You've also added a RAID, hardware RAID controller, so your disk I/O is going to be tons better. You've also added the IBM ASM processor, which is their advanced server management chip. Basically, it's a computer within your computer. It's on a separate power grid. And basically, it's the one that monitors the health of your CPU, the heat, the speed of your fans, and whether or not all your disks are online, that kind of stuff. And you can access that health monitoring chip through the serial port. So, you can connect to the chip, basically get a little login prompt, and then you can say, hey, I'm going to power the box on, I'm going to power it up, I want to reboot it, I want to see what CPU number 2 is doing. Did one of these systems fail? Is one of my memories, one of my SIMs offline? So, that to me is a heck of a lot more enterprise ready than the native X300, which has no brains at all. It's basically just a dumb PC. So, and when you consider like remote geographic administration of your systems, having better eyes and ears and ability to control that box is really important. So, again, is Linux ready for the enterprise? How about is your hardware ready for the enterprise? That's another big question you have to answer too. So, questions, comments? Anybody have a personal opinion on whether Linux is ready? Yes.
I have no opinion because I come from the world of Microsoft. But
is Microsoft ready for the enterprise?
Believe it or not, it's there. So, who's actually running enterprises on Linux?
Well, if you ask IBM, they've got a number of partners up in Europe that are, German Telecom or somebody who's running Linux slices on an S390. They've also got other European vendors, and I really can't comment as to who's doing it locally. What's that? You? Google? Or Slashdot? Aren't they? That's pretty enterprising.
Slashdot?
Yeah.
How many employees do they have?
Well, it's not so much the employees, but they definitely have, the enterprise characteristics.
I know, for example, that ISPs love Linux.
Right.
Yeah. So,
But they only love it in the right places. Again, they use it in parts of their enterprise. They don't use it in all the places.
Well, Google runs it on this.
all the ISPs I've
We
got.
talk about replacing NT server.
These are nickel and dime on the top.
Samsung 10,000 months.
Excuse me?
Google runs the
If
search.
you got
With 1,000.
As a primary domain controller, they have done that.
We haven't done that, no.
We replace like an NT file server. You can log on to have an actual like an NT domain. And you
Like we've done everything up to is having it be a primary domain controller.
Yeah.
The problem that I've always perceived with that is that you've always got Microsoft throwing roadblocks at you, because every time they release a new version, there's a lag with Samba that they've got to catch up, or they've changed their security model, where now the Samba server doesn't fit anymore. So now, as the rest of your enterprise rolls out Windows XP, now you're stuck with a Samba server that you've got to decommission while you figure out what's going on, and now they're redeploying over the
Microsoft size that.
She's also the principal for that.
I really can't comment on that stuff either. We've done it in on the underground side, not part of the actual company infrastructure, but like maybe in a lab where you've got 10 developers who just need access to their Windows laptop or something like that. There we've done that, but we haven't done part of the place. Others have. You read about it.
We did it for like 20 people.
Yeah.
Yeah, I interviewed at a company last week that, yeah, thank you.
How many days in counting have you been out?
I'm over in 9 months. Wow. Next week is 9 months of unemployment for me. And this is my 4th interview. 9 months. But they have a cluster of 25 FreeBSD boxes with 1 gigabit connection between them, doing heavy computational stuff. It's not, it's their own clustering, their own clustering group, and they've been very happy with it. Because not only does it cost less, but it costs a lot less to scale in smaller increments.
One product that I obviously forgot to mention when talking about Linux clustering is Beowulf. Beowulf clustering is very hot in the Linux spectrum. especially when you talk about like science computing things that are very large and for math type related things. I really don't want to get into it. It's a very complex subject, and we've had other discussions that went on for 2 hours. We talked about Fable below. So
We've had
that's a topic.
Fable who runs a Fable cluster here at MIT, comes in and talks about it every year or so. We'll get Kurt back.
NASA runs Beowulf clusters. I think there's another guy who runs Beowulf clusters with any PC he can find. Takes any junk machine he can find, adds it to his Beowulf cluster. So, there are supercomputers based on junk, and then there's supercomputers based
It
on...
has to be MIT, so you want to put a big cargo van.
All right, let's go ahead and move on to the Kickstart piece.
They need the cycles.
Yeah.
They do so.
So go ahead and hit the home button and bring up the Kickstart thing. All right, so in the same theme of Linux in the enterprise, in my opinion, anything that's running in your enterprise needs to be installed in simple, repeatable, unintended fashion. So that if I've got to roll out 100 boxes, I don't have to sit there and answer questions on 100 boxes to get the operating system to install. Windows seems to have mastered this with a product called Ghost. I'm not familiar with that. I don't, maybe SMS.
I've used Ghost before. If you're moving between disks that are different sizes or different letter sizes, you can end up with a lot of problems.
And that's why a lot of enterprise shops lock down what you can purchase for desktop hardware. They say you get to buy the IBM, I don't know, the IBM 600, which is now a 2-year-old box, but that's the only thing you can buy because that's what they have in the box. So, that's the way they manage that end of it. I don't know if SMS allows you to do it, but I'm going to look at that. I don't really comment on it. So, all right, so what are we going to do here? Same disclaimer as before. This is all personal experience, yada, yada, yada. You need to be responsible. Okay, what is Kickstart? It's a program designed by Red Hat, I believe. They continue to fund the product. It's distributed with all distributions of Red Hat. I think it was introduced somewhere around Red Hat 4 or 5. And even though it wasn't really usable in Red Hat 4 or 5, at least, the groundbreaking was there. With the Red Hat 7.2 release, the current version of Kickstart, also known as Anaconda, which is the installer, in my opinion, is very robust, offers a lot of flexibility in the types of installations you can do, and also offers very good customizability. So, what we're going to do here is we're going to look at Kickstart, kind of answer some questions about what it is, what it does. We're talking about how to configure it, and then we'll also look at the sample config files, and then we're going to do a live demonstration. Ooh. Okay, next screen.
How does this integrate into the enterprise concept?
Oh, okay, good question. Good question. How does this integrate in your enterprise? Well, like I said, if you're working for a company that likes to deploy thousands of systems at a time, this fits right in with that factory concept where you take a box and put it all together, or you have your vendor put it all together, shows up at the doorstep, and in theory, attach it to the network, pop in a floppy, turn on power, 10 minutes later, it's done building. Take it out, ship it off to your customer.
You have a desktop, I would say.
What's that?
You have a desktop.
Desktop, server, you name it. The Kickstart is flexible enough that you define what packages, how the disks get partitioned, what type configuration you want to run, what daemon start, what daemon stop. I mean, it's all, power is in your hands to make the system look like whatever you want it to be. So that's the nice piece. And you can create Kickstart configurations. If you're deploying IBM WebSphere servers, you can make a Kickstart configuration unique to that. And then, if the customer calls you, at a little location says, I want to build a WebSphere server, you can ship them a floppy in the mail, provided they have access to the internet or network or somewhere where you've made your package. They can build a box remotely because Kickstart has the ability to work over the network. It has the ability to work from CD-ROM. You can build a Kickstart file on a floppy and build your box from the CD-ROM, yet you'll get the same thing that you get from CD-ROM as you do from your network. And Kickstart builds your box. It's like a fingerprint of your hardware, the operating system you put on there. And
Is it interoperable? Can you essentially package Windows desktops, replicate?
No.
It has to be Linux?
It doesn't have to be Linux. It has to be RPM based. And most of the formatting of the file systems, everything else is, all geared towards ext3, or I think you can probably format it with BFAT or something. But it's all RPM based.
I have a real life problem. I have a network taken care of, where clients can download viruses along the way.
Yep.
It's just a pain in the neck setting them up all the time.
That's a perfect reason for remote Linux. You left that one open, sorry. I don't know what the answer is. I'm not a Windows administrator. I don't know what the right answer is for how do you manage Windows installations.
But whatever.
I think isn't there a remote installation server or something for Windows?
Well, yeah, it comes with 2000.
With 2000, yeah.
Maybe you could use.
Or SMS, you know, like an SMS thing. But we're talking about an organization with maybe 30 now.
Oh.
Give it a try.
One possible solution is you can take well, if you're talking about HPFS, again, all bets are off. You know, high performance file system, the whole Windows NT file system. Yeah, NTFS. If you take that, if you put that in the picture, all bets are off. I don't know anything about what you can do. But if you're still using, you know, regular MS-DOS FAT file systems underneath, you can hook up that box, you know, mount it up to a server and have a Linux box do a tar dump for that. And then basically create your image that way. And then save that. And if your system crashes, you reformat it with DOS and then you dump your tar back and you're ready to go again. You could possibly even DD the disk, but that would require you to take the disk out and install it in the Linux box. I really don't have any good answers for you.
That's where you want your box, because you are.
Yeah.
Well, actually, the DD thing will work over the network. That's basically what it manages.
Right, but you have to. I think you have to install like the Unix kit for NT that allows you to do that. I mean, the point here is that he's got Windows machines running. He's trying to figure out how he can
Windows client.
do Windows clients.
You can actually do that off of normally single floppy Linux boots, like the Linux Router project has a sub 1 or a toggles root boot.
That's a good point.
Yep.
Take a single floppy version of Linux. Boot the box. Have it, you know, if it has enough smarts to get on the network, then it could dump your hard disk to a remote server. And then basically you can store the images for that system, and then if you have to restore it, you again use the same floppy and then just copy your stuff back to your hard drive. That might be a good answer. All right.
It's
Let's see now. Let's go. I
COMS
don't want to go
net
Google.
slash RDK.
Come on. All right. Page 2. We'll go to Tom's reboot in just a second. Next one. We got about 45 minutes, and we still got to do the demo and also basically touch on the RAID tools. All right, I've already answered the question of what Kickstart does. If you're from the Sun world, it's the same thing as the Jump Start. Configurations are different, options are different, but the concept is the same. For the AX world, makes this be. All right, supported techniques for Kickstart. Again, I already mentioned that you can build your systems over an NFS shared directory on the network. You can do it from CD-ROM. You can do it from another hard drive on your system, provided all the RPMs are on the box.
And it
Or
does have to be another physically separate hard drive. It can't be a partition on the hard drive you're installing on your.
yeah. Or you can also do it from what they call a URL, which is FTP or HTTP server. Okay. So moving right along. So you asked about why do I want to do this? And I've already kind of answered this. Well, because it's quick and easy. It also encourages standards within your organization. It also, you know, in the event of a disaster recovery, this could make the disaster recovery a lot easier. Because a lot of times what you're paying for with these high-end backup products is you're buying into the, I need some way to get that initial system load on there so I can restore the rest of my data. Well, if the bare metal restore your operating system can be done from your Kickstart server, you know, oh, my system's lost, 5 minutes with the floppy disk, the base system's back, now I can just use dump and restore to get my application back on the box. So this could be the solution for your backups. And also, like I mentioned, it's also customizable. Okay, next piece. All right, so how do you create the Kickstart file? Kickstart file is a text file. It has a format. IBM's got their little book. Red Hat's got their little book. And basically, you can create it by reading the manuals and the formatting. And good luck to those who want to try that. Usually doesn't work too well because
similar to unattended text type of.
Yeah, it's basically like a set of responses to queries or whatever. But what you're doing is, we'll look at the config file in just a second, but basically it has like, how do I want to partition my disks, where are they going to be mounted, and what packages are going to be installed. And then when it's done, you've got a little post-install area where you basically just insert your own little shell scripts for things you want to do afterwards. And let's see here. Okay, so Another technique is, in the case of Red Hat 7.2, any system that you build, if you go into the root home directory, there's an anaconda-ks.cfg. That's a Kickstarter file that was generated for your system that you just finished creating. So if you do build a box from CD the very first time, you can take that Kickstarter file, dump it to your floppy, and now you can repeat that same install over and over and over again, hands off. This
It's like if you go through all the packages selection.
everything. That's the fingerprint of how your box will go. Okay, and Red Hat 6.2 provides a template on the install CD, and it's in the doc sample.ks is the file that's called, and that's basically a sample, and that's there to help you get started. The anaconda.cfg is only available through Red Hat 7.2. That just came out this last time.
7.2 has a sample on documentation CD.
Oh, well, yeah, if you guys download the documentation CD for it and say that the sample is there, which might be the same sample, and it might not have the same options because the Anaconda installer improved a ton since the last release. And they've really addressed a lot of the enterprise requirements because, the Anaconda thing was always geared at a box with a single hard drive or two hard drives. And if they assumed you had two hard drives, they assumed you wanted to use both hard drives for Red Hat. And so they kind of dispersed your operating system across the two. So there's a lot more options, and we'll touch on them in a second. And there's also a slick new utility on Red Hat 7.2 called ksconfig. And that's a GUI thing where basically, you fire it up and it says, okay, install the base operating system, and then it's like check marks for everything else you want in the box. You can set up your disk partitioning as if you were running disk druid, and then you hit go, create, it creates a little Anaconda config file, and then what you do is basically dump it to a floppy. Okay, we don't really have time to go into all these little things here. Is the floppy done right now? Yeah, so that's it. And you basically answer all the questions, and when you're done, you hit save, and it creates the Anaconda config file for you. All right, so mount the floppy. Let's take a look at the ks.cfg. Or is that the next thing on my list? Where to put the ks.cfg? Okay, well, where do you put that Kickstart configuration file? There's a number of different solutions. If you're running DHCP in your environment, you can put all your Kickstart information on your DHCP server. And that makes it nice because now the same floppy works everywhere. Because you put basically configure Kickstart to go to DHCP, put in your floppy, it comes up enough to bring up DHCP, get its IP address, and then we'll talk to your server, and it gets a configuration file there. In our particular case, DHCP is not an option. So our floppies are customized for each system because we have specific IP addresses on the floppies, and the Kickstart file is also installed on the floppy. Now, granted, if your environment's the same, the only thing that changes is the IP address. There's other solutions for getting around that. The only thing we're talking about tonight is the floppy install. All right, so how do you get that Kickstart file on this floppy? Very simple. You stuff the floppy in the floppy drive, you mount your floppy drive. As soon as you why don't you just experiment? Okay. So you mount your floppy drive with mount floppy. Ding. And what you do is you copy this anaconda.ks.cfg to the floppy. Of course, you want to rename it to ks.cfg. Take off the anaconda part. And this is what the file looks like. And I really don't have time to sit here and go through all the options, but you can kind of see that you're telling it what kind of mouse you got, what kind of keyboard you want. Here's the partitioning information up there. I don't have my laser pointer with me today. But the partitioning information, basically, here I've got boot. It's an ext3, I'm told 25 megs on hard drive A. On disk, HDA was something that was introduced with Red Hat 7.2, and it's very important. Because again, if you've got multiple disks in your system, you'll be able to specify where you want that boot. Okay, and then there's swap, bar, and temp. It's all pretty straightforward. And it is documented in their books, but for some reason, when I followed the procedures with, put these parameters, I couldn't get the Kickstart file to work. Basically, what I had to do is run a system one time with a CD or a network install, and then I copied the anaconda.ks.cfg and basically used that as my template. And then I deleted all the packages that are defined and just recreated my package list. I left all this header funk at the top. All right, so I'll scroll down. Okay, so here's the main part. What are we doing? We're installing packages. This is the list of packages that I decided to put on my box. This is what I would consider to be more of a server-type configuration. There's no X, I've taken out all the multimedia stuff, all the games. I've stripped all the garbage out that I don't need running in my data center. That's why when this box builds, the whole operating system almost fits in about 200 megs. It's really tiny. That's the list of stuff that goes on there. The Red Hat Anaconda does a nice job of doing all the dependency checks. And basically, if you create a list of packages that don't meet all the dependencies, it's going to interrupt itself and say, oops, you're missing this package. So at that point, you got to go modify your Kickstart file and go add something in there. But for the most part, it's, if you do it 1 or 2 times, you get the configuration file all set, then you're done. And then at the very end here, you can see that there's this post section. What's nice about this is this gives you an opportunity to run your own little shell scripts. Shell scripts can include anything, like contacting your server and mounting a directory and then installing other RPMs that I've developed on your local box. So this is the perfect place to do your little customized pieces. So all that being done, all right, let's go ahead and pop this guy off. All right, this is my 266 megahertz Celeron, which is overclocked to 400 megahertz. And today I went to Micro Center and I bought myself little removable drive trays for this experimentation here. And 14 bucks. Can't beat that. That's awesome. Now I don't even have to open my PC to take my hard drives out. Every time they fail, we don't take that one out, go to the dump, and go find a new one. For those of you who don't know the story, I went to my town dump a couple of weeks ago, and I found a perfectly good HP Pavilion, 400 megahertz Pentium 2 system there. Had one SIM that was bad, so I took it home and cleaned it up a little deodorant. It was fine. little Febreze and a plug-in in the back. That's what's running my web server. That's what runs my linuxboot.com, the old Pavilion box. I just thought that was fitting. Okay, so here's what's happened. The box is rebooted. It's now reading a floppy. I guess we still have a little bit of time when it actually reads its kernel. But I've created a custom little display just like you would with Lilo. I gave it a boot message. I removed the standard Red Hat boot message that basically says, welcome to Red Hat, here's all the colored screens of all the things you can do where you normally type, install or rescue, whatever. So I've replaced all those screens with my little custom thing. And then the other piece that I did, we should go back and look at it, but on the floppy, there's 2 files. One's that boot message where you can put in your custom text, and the other is the sysconfig, which is basically the Lilo configuration file for the boot floppy. Inside the sysconfig, you need to add a ks equals floppy line to the append section. And that's what's going to tell your kernel, or the boot kernel, that this is a Kickstart install and the configuration file is on the floppy. So as soon as we're done with this sample installation, and you can see it's already going. For those of you who weren't listening to me and were actually watching the screen, the box came up, said, I'm going to go talk to the DNS server. The little box is also set up as a DNS server. I'm going to go find out my host name. The floppy has a pre-configured IP address on it, so it already knew how to connect to the network. And then basically the Kickstart file said, oh, that guy's my NFS server. I know what directory to go to. Found its stage 2 of the Anaconda install, which is another RAM disk, init-rd type image, basically loads it into memory and mounts it, and then goes on with the second piece of the install. But as you can see, it's already getting busy installing the packages. This piece takes about 5 minutes because the packages are all installed on the server. And like I mentioned, this is just doing NFS. And what I did to create the NFS directory is I took Red Hat CD number 1, mounted it up, did a little tar, copied all the data into a directory. Took that CD out, added another CD in there, and did a tar to the exact same directory. I kind of overlaid the 2 CDs because the 2 CDs don't actually share any of the same data. And so the RPMs all ended up in one giant directory. That's how I created the directory on that server. Yes?
Except for, I think, trans table?
Well, the trans table I think is identical in both boxes. It's basically the trans table is how do I translate the name of a package into what the actual name on the file system is.
And it's not used by the Kickstart install, so that's not an issue.
Yeah, it's just if people are doing it, they might see this error and tell them it's okay.
Yeah, the tar will definitely complain saying, oh, there's the README, does it already exist? Stuff like that.
Yeah.
But it's all inconsequential and you shouldn't care about it. So here we are, 2 minutes into it, we're almost done with the system build. And technically, you know, if this was my server for the production environment, when I'm done here, flip, I unplug it, go stick it on the data center shelf, and it's ready to go. For the most part. I mean, you can configure it to do it all, yes.
Does Kickstart make the bootable CD, or you made the bootable CD yourself?
What bootable CD?
The CD that you put in that?
Oh,
The floppy, I mean, floppy. I mean.
The bootable floppy that I'm using is the Red Hat bootnet.image. So in the images directory on the Red Hat CD,
Right.
there's a bootnet image. That's what you start with. You take that, you basically dump it to a floppy, mount the floppy, you DD it to a floppy, then you would, do the old mount MNT floppy, mount the floppy so you can access it. Get rid of all the messages file so that make yourself a little bit of room on the box on the floppy, and then just copy that KSCFG to the floppy.
Okay.
And then you modify the boot message and the sysconfig to say KS equals floppy. We'll look at it here in just a second.
Make your own kernel, bootnet doesn't have what you need.
What's that?
You can make your own kernel.
Yeah, that's something I had to do personally. For reasons unknown, Red Hat decided that the TLAN driver, which is the compact standard for all their hardware, didn't belong on the actual bootnet floppy. They made it available as a driver disk. That's not really an option for a jump start, because my whole idea is I don't want to be there to switch floppies. And if I'm going to have somebody else do it, I want to have them put one floppy in and then let them get on with their work. I don't want to have to sit there and waste their time doing the driver disk thing, because then I have to create manuals on how to do it so that they can page through and go, oh, I pushed the button and I stick in a new one now. So, anyway, what I had to do in that particular case is the boot floppy is an init.rd image on it, and then you have to unroll that and add device support, remove device support from things you don't want so you can create more space on the floppy and add it back in, and then you have to roll it all back together. There's a couple of how-tos on how to do that. I don't really plan on getting into that tonight. Okay, so Gordon's mounting the local bootback image. This is bootnet floppy, and as you can see, this is the normal bootnet floppy. And what you'll see is there's that boot message file. You can get rid of expert, general, anything that ends in, what are you doing? Go back. You're killing me.
Just
All right, get rid of all the message files except for boot message, and then you can, put whatever friendly text you want in there that you want. The whole idea behind the Kickstart anyway is to make it automated. You don't really want to have anybody respond to anything.
Boot message is that standard screen that you first get when Red Hat boots up and you're about to install or upgrade or whatever.
Okay, and so there we go. The steps. Get rid of all the message files. That usually gives you enough room to put your KSCFG on there. And then in the sysconfig, you can get rid of all the labels except for the one that says Linux at the top. And then, for the most part, you can get rid of everything after append and just put KS equals floppy in there. Like this. KS equals floppy. And that's all you need. And that's enough to tell the boot kernel that you want it to do the Anaconda Kickstart. So, I'm sorry, it's a lowercase k. It's a Windows thing. It can go uppercase or lowercase. All right, so I think we should be done with our install. Let me flip the video here real quick. Ready? What did you do?
I went to a
I thought you
video.
What I really wanted to do is get this guy on the serial console so that we could just serial console over to it, because I actually have an RPM package that I developed that basically adds serial console support to your console in Lilo. But I didn't have time.
Hard drive activity.
Yeah, it's probably doing the post install. Yeah. One thing I would like you to do, Gordon, is go to, doing the post install, is go to the second or third virtual console so that we can see the custom piece going. When we get into the RAID tools, notice that all the drive activities up here, this is hard drive A. This one is on the second IDE bus. It's not on the same bus. So this is A and this is C. So when we do the Kickstart in our next phase, the RAID tools, you're going to see that Anaconda is going to configure these devices as RAID 1 mirroring. So you see both these lights flashing. Okay, so here it is. It did it. This is Virtual Console 3, and basically this is where the output for all the RPMs that get installed. This is standard out for all those scripts that run. And so I developed a little script, and you can see that's the output from the actual piece in the KF.CFG that we looked at just a bit ago. Soup configuration begin, it mounts the information, it runs my little post install, and what the post install does is basically just echo some text into a temp file in temp.
For those who don't know, that when you're installing a Red Hat system, you have 4 to 6 virtual consoles you can get to by pressing Alt and then a function key. Alt F1 is the first one, that's your primary. Alt 2 is a shell.
And that's all residue of the projector back there at the top. It's not my system.
Yeah.
Wink, wink.
Device configuration and
Kernel
detection,
messages. Yeah. Okay, so go back to screen 1. And we're done. System's installed. We reboot, it comes up. I don't know how interesting it's going to be to watch a Red Hat box proof, but I'd like to get started with the RAID thing. So what we've done is we've created a, we basically took this Kickstart with non-RAID and we added RAID options to the Anaconda installer. And let's go ahead and look at this while we let this box move. All right, so at this point,
Is the reason that the Kickstart went so fast because you installed so many packages?
yes, exactly. Well, plus I didn't have to sit and wait for my slow typing. Yes, enter. Let's see, was there anything else that I need to bring up about the Kickstarter? All right, I already talked about configuring the server. Create a public NFS shared directory. You have to modify the /etc exports file to make sure it's shared. If you make it read-only, you should be able to share it to the world. So, depending on how good you are as an administrator and how good you are at segmenting the different rules for your exports, that's the easy way out. Take a look at the FC exports file real quick. Or just open another shell. Okay. FC exports. There you go. I've got 2 lines in there. One's called public OS. The other one's called public baseline. And they're shared to everybody read-only. So I don't really care if anybody could install Linux from my servers. WAN. And then also you have to make sure that NFS is running. So if your box doesn't start NFS by default, you have to run a little etc init.the NFS start. And the utility you can use on Red Hat, I don't know what the others are, but there's a utility called chk config. This allows you to add and delete those little RC scripts in the various run level directories, rc2.d, rc3.d. That's basically a little management utility, basically turns them on or off. You do a man on that, get the syntax. It's real easy to use, and there he goes. Okay. Newer features, like I already mentioned, the on-disk feature, allows you to specify which disk this partition is on. Also allows you to actually specify what partition of the disk you'd like to use, the on-partition option. And then there's also one called force primary, so that the Anaconda doesn't just keep creating partitions and in the extended partition area, like 5, 6, 7, 8, 9, 10. Okay, other coolness. Keep going. Let's go to my other coolness features. All right, I already mentioned you can create your own little post install. And again, if you're using DHCP, you can really make this easy because you keep the chaos.cfg files on your server and you make the floppy just basically the same floppy everywhere you go. And then also the new version, the new install Linux loader, not Lilo, but Grub. My understanding is it has a version of Etherboot built into it. And this is something new to me, but I'm hoping that I might be actually able to use Grub to initiate kickstarts over the network. So using Grub, do a little DHCP, now I completely dissolve the need to have the floppy altogether. I've got a Sunbox and a PC. I can boot from the network without any other OS being on the system. Kind of a cool concept, especially when you talk about geographic distance between me and my servers. Experimenting and setting a Kickstart floppy to use a serial port. This is one of the things I'm kind of looking into Ideally, I'd like to be able to manage the entire install over a serial port because those are my eyes and ears to my boxes. I don't have a monitor and I don't purchase those special little cards that do PC anywhere over a network. So if I can attach it to a serial port, the ideal way for me to do a kickstart would be through the serial port. And then of course the serial plus rub is my theory, the totally unattended system remote load. So that's the end of Kickstart. We've still got a little bit of time left. Let's go ahead and start running with the RAID business. Why don't you quickly bring up and just show the quick differences. If you look at the partition layouts, it's a little bit different. We haven't been able to determine exactly what the rhyme or reason is for the numbers they choose. My only assumption is it can be similar to the Sun metadisk concept, where you just have arbitrary numbers that you use to refer to your meta devices. And, you know, that's going to confuse half of you and others will get it. But basically, I'm saying create a RAID device on this particular hard disk, create a RAID device on that hard disk, here are the sizes, and then at the very end, that's where I tell Anaconda, okay, now RAID those two file systems together and make me a mountable file system. And that basically is the piece that's the piece that binds those two devices together and turns them into one logical device to the operating system. Okay, that really is the only difference between the two Kickstart disks. So let's unmount that mother and get this guy started. And what my main point here is what I'm hoping to do. If I'm on it, what I'd really like to do is get this guy kick-started and rated, and then Gordon will play some RAID games for you. And since I haven't done this, I don't know what's going to do my hard drive. I'd actually like to power off one of these disks and watch the system stay up, and you can see all the messages live.
What kind of drives?
These are my drives that I got from the dump, so I'm still okay.
What protocol do they talk?
Oh, these particular disks in here again are IDE disks. So
Not meant to be hot swap, hot plug by any stretch of the imagination.
They're not even different UDMAs.
yeah,
Yes, they are.
this one down here. We tried to get two similar disks, but the dump wasn't open today. So we had to go with what we had on the shelf. So we've got like an 8 gig UDMA 66 drive. Okay, and this is a 6 gig or 7 gig, and this guy here is a 2 gig drive.
Doesn't that cause a problem in trying to
No.
bring this together?
No, because on neither of those statements did we ever tell it to grow to use up the rest of the disk. We were very specific. So basically, and we also said, on partition, on disk, we were very specific in how we formatted the drives. So shouldn't be a problem. We're just going to have an awful lot of unused space on this disk.
So the two RAID partitions have to be the same size, obviously.
You can only
What's that?
mirror.
Mirrors have to be
I'm sorry.
Yeah, mirrors have to be identical size.
Three 2 gig partitions for RAID.
We're doing mirroring, RAID 1.
Okay,
So we're basically taking the boot partition, mirroring across the two, which are two 25 meg file systems, and then basically we've left the rest to root just to keep things simple, and a swap. One quick point is that the Red Hat 7.2 Anaconda does not allow you to mirror swap during the kickstart.
You don't want to.
Actually,
you do.
I do. Why would I not want to mirror swap?
Why would you want to wear a swap?
If my hard drive where my swap exists dies, my system's hosed. You have to mirror swap. And typically you're getting a performance gain, because if your RAID intelligence is smart enough, it should be round-robbing writes to either disk. So your performance should be a little bit better with RAID 1.
So is it reads, not the right?
The reads, right. Yes.
I was just wondering if there's a utility that ran a similar type of functions where you want to actually like ghost a Linux system. Instead of running, some of the boot sequences
DD.
and duplicate, packages, there is a way of
If you create one image and you have it on the same hard drive, you can run DD, which is just dump or dump, whatever. You just copy bit for bit from one hard drive to the other. You can do that. That is Ghost for all practical purposes.
There was a Linux thing called partition image, and I tried it. Supposedly it's a la Ghost, and it allows for the growing.
What's the, that partitioning tool allows you to grow and shrink things?
Magic?
Hardnet, or Hardnet. That's an open source project allows you, it's kind of like FDS, allows you to go in there and say, oh, I want this file system, this directory activity.
Both these systems come with that.
Yeah.
Actually, Red Hat 7.2 does also.
7.2 came with it.
So, okay, as you can see, it's already running, and both disks are flashing. One thing you'll notice is that this disk down here, I think, flashes a lot less than this guy. You know, I see a little disk I/O going, but every time there's a major read or write, this guy sits there and hangs, while this guy just goes flip.
Because it's one of them is UTM-8.
One of them is much faster, yes.
And those of you who are familiar with IDE hardware, all the servers at home are all SCSI. But what I understand is there's the Tune 2FS or something like that, allows you to turn on DMA rights for
HD farm.
HD farm. That's what it is, HD farm. And you know, from what I've read, a lot of people claim miracles, they improve their hard drive throughput. Other people say, go ahead, wish on. Really, the logic's not there to support that theory.
It's a big improvement over when I had it turned on. Compared to SCSI, it's still
And it depends on support in the hard drive controller and motherboard. Basically, all three pieces have to play well, and then you can turn on that feature and get some performance out of it.
What's your opinion on RAID 0, 1, RAID 10, or RAID 5?
Well, RAID 10 is RAID 1 plus 0. Different reasons for doing both. You've actually got the, did you draw the diagram somewhere?
I have a 0 plus 1. I don't have a 1 plus 0.
If I remember correctly, RAID 0 is striking.
Yes.
You take multiple disks, you turn them into one disk. RAID 1 is mirroring. So 0 plus 1 is where you take a bunch of disks, you stripe them, and then you mirror them with another bunch of disks which have been striped. You're paying different, I used to know this off the top of my head. There's different performance rules. You have to consider whether you're losing more by the mirroring logic or by the striping logic, and then also in the complexity, because your ability to grow volumes, whether they're one or the other, becomes a little bit more tricky. I usually just, my model is take your OS, mirror it with another disk, and then use a product like, I don't know, Veritas Volume Manager or some other big product to manage all your volumes. But typically what we do, or what I've done, is stripe and then mirror. So yeah, stripe and mirror.
You do RAID 5 often or not?
Not in software. Performance kills. RAID 5. What's that?
Or RAID 4?
RAID 4, yeah. RAID 4 and RAID 5 is a little bit different. For those not familiar with it, RAID 4 allows you to take a number of disks with a single parity disk, and RAID 5 basically is more complex, and they stripe and mirror the parity across the disk. So I'll turn it over to Gordon when I talk about RAID, and I'll watch this guy move. Here's Gordon.
I've noticed on the board.
Let me play games on the computer while he's talking.
Too bad.
For anyone not familiar, RAID is just an acronym standing for Redundant Array of Inexpensive Disks. Somebody figured out 10, 12, 15 years ago or more that instead of making individual drives bigger and bigger and bigger and having them be a single point of failure, you can take a bunch of little cheap drives and glom them all together and now have some redundancy and have more flexibility and have more room to grow. Current techniques involve RAIDing either in hardware or in software. IBM, Compaq, a number of vendors all have hardware cards where you can plug in SCSI channels, numbers of drives on those SCSI channels, and manage them as stripes or mirrors or RAID 5 sets. I don't know of any that will do RAID 4 at the hardware level, but that's a very uncommon RAID as far as RAID levels go. In software, you've got some of the big players, EMC, Veritas, and IBM have RAID tools to manage that in software. Linux now has, just in the last few years, gotten RAID tools for managing RAID striping and mirroring. It will actually do RAID 4 and RAID 5. We'll get into what those are shortly. He's kind of already, Christoph touched on what some of the levels are. Is there striping, you stripe your data across disks. Similar to that I didn't write up on the boards is a RAID level called linear. I don't know how specific it is to Linux, that Linux does support it, and that's basically a concatenation, where you have one hard drive and you RAID it to another hard drive, and instead of alternating the writes between those drives, it'll fill up one disk and then just go on to the second one, but they still both look like they're one big disk. RAID 4 is sort of striping with parity. So you have 4 hard drives, you write data to one, you write data to another, you write data to a third one. Each time you write, it performs a checksum across all of those stripe areas and writes a parity section to your fourth disk. No live data that sits on that parity disk is always for a checksum. So that if one of your drives fails, that checksum can be used to recreate the data and you're still up and running. And I'll get into some of the benefits of different levels over the others.
Can I just ask real quick, who's not familiar with parity? I'll be glad to give a little 10-minute what parity is, and they'll show you on the board after we're done here. So if you want to hang around, I'll be glad to answer that question quickly. It looks like I like a jazz team.
Yeah, IBM drew the pictures of the first disk drives back in the 60s, and they stuck.
It's like oil drums. Okay.
They work. So you've got a 10 gig drive and a 10 gig drive, and you're going to use RAID 0 to strike those. They're now connected in that you're going to write one block of data here, the next one you're going to write here, the next one comes back to here, the next one comes back to here. I don't know what the upper limit is, but you can strike, several disks in a row and get better performance and more disk capacity than in a single file system. So having a 10 gig drive striking a 10 gig drive is going to give you 20 gigabytes of actual usable space. But what that doesn't give you is any kind of redundancy or fault tolerance. Mirroring, RAID level 1, also in this example we use 2 drives. However, when they're connected and it writes a block, it also writes a block over here, so that both disks now have the identical data written at the same time and committed by the operating system at the same time. The next block is going to get written here and here, and so on. So if you have those same 2 10 gigabyte drives, you don't get any additional capacity. Your usable capacity is only 10 gigabytes. But now you have that fault tolerance. If one drive fails, you still have all of your live data on the second one. And no data is lost, and you can hot swap drives. I haven't tested this, but the recent versions of the RAID tools imply that you can hot swap a drive out, put a new drive in, and have the tools recognize the new drive and resynchronize the data between the good mirror and the brand new drive.
The RAID 1 mirroring is your optimal security. You've got the exact copy of the disk. Disk fails, you still have the same disk. But it's awfully expensive because if you have a lot of disks, you've got to have twice of your data. You've got to have twice the capacity. Hence the next version of the RAID that he's going to talk about. The objective here is to produce less reliable redundancy, but you're basically getting better bang for your buck.
In RAID 4, we introduced what's called a parity disk, where when you write a block of data here, it calculates a checksum here so that you can recreate this data if this drive fails. The second block of data would get written here, third here, fourth here, and so on. Anytime a write is done, checksum is performed across all of the stripes in the RAID 4 disk set, and a sum is written here so that if this drive were to fail, you can use this checksum and the data on this drive or as many other drives as you have and recreate whatever it was here so that no data is lost. And using the 10 gigabyte example, each of these 3 is 10 gigabytes. This is live data, this is live data, this is strictly for parity for data recovery. So you're given 20 gigabytes out of the 30 possible total usable space.
Think of parity as kind of like odds and evens.
Yeah.
If all your data is ones and zeros, which it physically is, each data block is basically lined up with the block in the next box and says this one's 1, this one's 0, your parity is 1. If my data blocks are all zeros, my parity is 0. If I've got 2 1s, it's 0. So basically, you're calculating odds and evens. So if you lose a disk, if you do your math, you can recreate a disk by recalculating the parity because you've got basically two knowns and one unknown. That's standard math. I hope.
Does that option have a performance loss compared to number 2? Does it take time to recreate?
Here's the deal. I mean, RAID 4 is something that the network appliance uses. They do it in hardware. It's all front-ended by an enormous amount of cache. Performance of the actual RAID calculation is negligible because your box is communicating with the cache. So if you do it all in software, yeah, there's a huge penalty for it.
There is going to be a performance hit on two levels, because not only are you calculating the checksum, but you're having to hit this one drive for every write operation that goes out, no matter what drive it's actually touching. So you could hit a bottleneck by doing all of your parity calculations to this one hard drive, which brings us to RAID 5. RAID 5 is that same parity concept, only it's distributed across all of the disks. As you write your data out, one of the slices across is your parity slice. So that the data chunk will be written here, and the parity calculation will be calculated in this one area of this first disk. When you write another chunk, or another chunk, or another chunk across this slice, this one section on the second drive will, for example, be the parity section on this set of slices across all 4 of your drives. This is now the parity section. So you don't have that single hard drive bottleneck of calculating your checksums all going to one hard drive. You now have that distributed. For this type of RAID, 5 is by far the most popular.
Let me interject one quick point. RAID 4, newer versions of RAID 5 allow you to grow and add disks to them, but that's only happened in the last couple of years. If you want to add a disk to a RAID 5 set, the usual procedure was to take all your data off of it, rebuild your RAID 5 set, and then dump all your data back on it. That's kind of changed a little bit. RAID 4 has a nice feature of if you want to add a new disk to it, you just put zeros all over your disk because that doesn't change the parity. Once the disk has been zeroed out, you add it to the RAID 4 set, and now it just becomes part of your data structure. So it's real easy to grow your RAID 4 sets. In the past, it was impossible. I don't know if you can grow RAID 5 in software. It's typically a hardware thing where they migrate your data around and then insert stuff into them. I'm not all that familiar with it.
I don't believe the RAID tools allow you to grow.
Has anyone ever experienced data production with RAID 5?
Yeah. The one problem that you run into, especially with RAID 4 and 5, is that you are protected against a single disk drive failing. If you have 2 disk drives fail, you're dead in the water because you've now lost the live data and the parity calculations, so you can't recreate what data was on the drive that you lost.
RAID is not really a replacement for backups.
No.
That's why I had it as 2 separate topics in the whole enterprise discussion. Backup is its own little category.
Yeah. RAID will protect you from periodic data hits and periodic hardware hits to a specific disk drive. Again, if you lose 2 drives, you've lost
It's all a lottery game. I mean, the goal here is to improve your availability. And the likelihood of you losing 2 of the same disks in the same RAID 4 RAID 5 set are very minimal. Obviously, if you build a RAID 4 set with 100 disks in it, your chances of having 2 disks fail in the same general vicinity are more likely, especially if they run for a long time and you've never replaced any of them. There's a good chance at some point they're all going to start failing around the same week. Especially if you have a data center power failure or something like that. Does this spin down? I bet you 50% of them don't come back up.
So that's where you're.
Especially on buying them.
And this also doesn't protect you against somebody actually deleting their entire column directly. And it's very uncommon, but one disk drive failing can take out an entire chain. It's, again, very unlikely, but some sort of power spike or something along those lines could take out more than just a single.
Every hard drive's got a little bit of logic chip in it. If that logic chip is the piece to go, it could just turn a wire on the bus on and leave it on so that no other disk can talk. I mean, usually it's the mechanics of the hard drive, heads, motors, it's those things that fail. But anything can fail on the hard drive. So again, when you're planning good storage management, you've got to split your disks on different buses. You've got to mirror across controllers. Don't just mirror your disks on the same controller. Because if this disk goes bad and it takes the whole controller with it, this controller is still going to be safe. It's unlikely that this disk damage is going to spread across the motherboard and impact this guy. But these are all the things you want to consider when you improve the redundancy on your system.
Especially if you're going to try this on a PC, put your two IDE drives on the separate IDE controllers. If you put them on the same controller, you can tell it to do some operation, go have lunch, and then come back. In particular, write performance to two ATA drives on the same controller. You don't even need to be using the word performance at that point. Yes.
Might be running Windows NT. Is there a difference in the performance hit and the rebuild between 4 and 5? Because you need some time to rebuild from parity.
I believe you have better performance rebuilding of 5 because your reads are going to be distributed across the disks, as opposed to all the reads coming from your one drive.
So again, you get to that bottleneck.
Right. Again, you're getting away from the single parity drive bottleneck. Yeah.
And that's the rebuild time on RAID disk is a serious issue because as vendors start to deploy 36 gig, 90 gig, 180 gig drives, rebuilding a disk can take hours, even on high performance systems, and those are hours which your RAID volumes are exposed. So if you do have another failure, these are things you have to consider. Do you want to buy a giant storage box with 180 gig drives on it? Because the likelihood if you have one fail, and now you're being basically exposed to a second drive failure scenario, could be hours as opposed to minutes that you get 18 gig drives. Yes?
When you rebuild, you're going to have to read all the data on all the remaining drives. There's no way of getting out of that.
Correct.
It's not just the parity drive you're going to read, it's the whole set.
Right, because you have to compare that parity data with the rest of the data on the drives that are still good in the RAID set in order to calculate what needs to go on the new drive. Correct.
So if you do this while you're up and running, the whole point of it just kills your performance as you're
performance will noticeably slow down, yes.
In most cases, RAID 4 and RAID 5 are implemented in hardware. You're paying for external hardware not built into your system, unless you're getting like a special controller. But technically, you're paying EMC, Sun, IBM, Compaq. You're paying one of those guys to sell you a box that does all this in hardware so that performance penalty is kind of hidden behind the cache. But even then, you're going to get considerable degradation of services when the system's rebuilt.
The better hardware also has a throttling function. So you
Yep.
can say, I only want to give 30% of the bandwidth over to the rebuild.
You almost have the capacity to give it a nice level,
Yeah.
nice 10 in the rebuild, and then it just doesn't take hours, and it takes days.
Yes.
Speaking from experience, right? How do you calculate the capacity of the RAID 5 then?
So you lose one drive.
You basically lose one drive to parity. Yeah. Because one slice as you go across your disks is going to get lost to the parity, eventually all adding up to one physical hard drive. So out of 4 10 gig drives, you're going to end up with 30 usable gigabytes of data. Now, you talk about a combination of 0 plus 1. There's a number of combinations. This is just one of the simplest. 0 indicating that you're first going to stripe data across drives, and then 1 indicating that you're going to mirror two striped sets together. So these are our first 2 stripe sets, and we write a data block here, and a data block here. This is another striped set together. That same first data block is going to get written here, and that same second data block will get written here. Now, because these are striped, these give us a usable total of 20 gigabytes. These are striped. These give us 20 gigabytes. But because these are mirrored, we only get 20 usable gigabytes out of the 4 hard drives. Again, that's very redundant because we have 2 exact copies of all the data. But given 4 hard drives, that's not as efficient as the RAID 5 set was. The performance levels are really going to depend on the hardware you're running on, the operating system you're running on, whether you're using IDE drives or SCSI drives, or 10,000 RPM or 15,000 RPM drives, whether you're using SCSI 1, 2, 3, Ultra, 160. There's what level of caching is on your hardware controller or the disk drives.
The 2.4 kernel now supports SCSI
Tag
tag
queuing.
command queuing, which is supposed to be an enormous performance boost, but it has to be supported by your hard drive and your controller. I don't think it's enabled by default. So if you've got like Adaptec controllers and Seagate disk drives, I think you might want to look into that. And it should be just a little proc file system option. You just cat 1 into some kernel option inside the proc file system, and that basically turns it on. And then you get big time performance gains, especially because what happens now is that your SCSI hardware, your SCSI chips are allowed to basically queue up a ton of commands and send them across the bus in one shot, and then the disk basically, kind of like, I don't know, it's like this fast. Okay. Gordon, the question is, what RAID levels do the RAID tool support?
The linear, which is just the concatenation, 0, which is the striping, 1, the mirroring, 4, and 5. Almost all of the RAID levels that are out in use today. Just for those of you who are curious, there are RAID levels 2 and 3. 2 is a very low-level checksum sort of computation that required an extraordinary number of drives and a very complex controller that really didn't give you any significant benefits compared to RAID 4 or especially 5. I forget the details of RAID 3.
They're not important.
But yeah, it was not important enough to make it a worthwhile RAID set. RAID 6, if I remember right, is RAID 5 with an additional set of parity checksums so that you now can withstand 2 hard drives failing in the same RAID set.
That considers 5B or
It could be. Yeah.
I don't understand the difference between striping and linear. It sounds like in both cases you're just writing across drive.
Not quite. With striping, you're actually alternating your writes between the hard drives. So that if you're writing a lot of data at one time, you're writing one chunk to the first drive, while that's often going to writing the second chunk to the second drive, getting much better performance. Linear is simply concatenating, where you write serially onto the first drive until it fills up, and then you start writing on the second hard drive.
So linear doesn't speed anything up, but it just lets you put something bigger on a small.
It lets you create larger file systems.
Right.
If you've got 2 gig drives, you can create a 4 gig drive and then basically mount it with a big 4 gig drive.
And also is that the linear allows you to have different hard drive sizes.
Yeah, it allows you to mix and match hard drive sizes. If you got, 2 or 3 1 gig drives from the dump, a couple of 500 gig drives from the dump, you can combine them all to create, your 750.
You have to show us where this dump is.
It's an ongoing process. Just take your recyclables to the dump instead of putting it on the curb. You tend to find a bunch of junk that way.
The Linux RAID also supports the concept of a spare drive, which is a hard drive that's just sitting there idle, unused, and is ready in case one of the other drives fails when you're using RAID levels 1, 4, or 5. Anywhere you have redundancy in your RAID setup, a spare disk will kick in if one of them fails. So when you're using the RAID level 0 or the linear, you have no redundancy, so if one drive fails, there's no way to recreate that data. So having a spare doesn't do any good. Yes?
So 0 is just finding your performance. There's no extra.
Zero gives you performance and gives you that sort of abstraction where, again, the two gig drives could be made to look like one 4 gig file system.
There's no redundancy.
No redundancy at all. No.
The Linux mirroring system files also mirror.
It can boot from either disk.
Yeah.
Basically, we'll test this in just a minute, hopefully. What I want to do is, as soon as he's done, is I'm going to turn the power off on this disk. Hopefully the system will stay there, and then we'll reboot the box and launch it boot from the other disk. What happens is that Lilo has to get some extra configuration information, and basically you're going to configure Lilo to look at the meta device, the MD device. If you look at the little DF-K, you'll see my devices are no longer dev, HDA, or SE, or whatever. They're little MD numbers. That's a meta device, and that's basically another abstracted layer from the kernel. The kernel doesn't see both devices. It's basically the device driver that knows how to communicate. So when the disk boots,
Here's a couple of lines from the lilo.com file where you specify that your boot file system is in fact dev MD3 or whatever meta device your boot file system is. Yeah, there you go. Yeah. Fourth line from the top, boot equals dev MD0. And these were set up in that Kickstart config file. I actually specified what MD devices to use. As you're going through a regular Red Hat manual install, you can tell it to set up a partition and make it a RAID partition, set up another one, make it a RAID partition, and then set up a file system on that RAID pair. And it will assign an MD or meta device number to it.
Are we ready? Should we go do this? Sure. Or is something else I want to talk about first? This is like the end all of yay, no, and then everybody claps and cheers. Is there anything else you want to talk about?
Go to another virtual console and do a tail on the messages.
That's what I'm doing right here.
Oh, okay.
It's the tail of the messages.
All right. Make it so.
What's the RAID tab?
The RAID tab file is a configuration file that tells what RAID devices you have, how they're laid out on what actual physical partitions, what RAID level you're using. Go ahead and go to the extra directory and do more.
For those familiar with the Sun Solaris ODS product, this is similar to the md.tab file for the Solaris stuff.
So Lilo must read that RAID tab file.
No. Yeah. I don't
Somehow it has to know where to find
the boot
your...
kernel is RAID aware. It knows what meta devices are and how to talk to them.
But that's really
right, but Lilo is going to... No, Lilo just points to the device, the dev MD0.
Right, somehow it has to know how to get what MD0 is made out of.
No, all it cares is that the boot device is MD0, and then the kernel takes it over from there. Because MD0 has a major minor number, knows what device, what modules.
Exactly.
Through that logic in the Arduino.
Yes.
Device, it actually writes a header at the beginning of the partition of each of the different partitions of the different drives, and the kernel driver itself reads that information off the disk. It tells the kernel driver how the disks are all laid out. So it's not in a file. I mean, it is in a file. You're looking at it there, but I think it's also a kernel to give you without needing a file system.
Right. In the Veritas world, this is called the VTOP, and basically it's a little partition on the disk that preserves information about all the other disks in the system, so that when the system boots up, it can look at any VTOP on the box, basically figure out what's going on in all the disks. In the Sun world, they call that the, what they call that command they run. You create these little DBs, little databases on the disk, and you're supposed to have multiple databases for all your...
ODS?
Yeah, MetaDB. The MetaDB, that's what it is. It's the little meta device database, yeah.
Part of the way down there, one of the options is persistent superblock, which is an almost given in the RAID set today. That tells the RAID tools to write a superblock on each disk in the array so that any one of them has all of the information about all of the drives in that RAID set. So that when the system's coming up, it can look at any superblock in the RAID set and sort of auto-discover what the whole RAID set is supposed to look like.
Okay, let's do this. Okay. All right. Little do they know, when they sold me these things, they said, oh, it has keys to prevent you from removing the disk while the system's live. Little do they know what keys all that plan. I mean, Mark, it said,
Die. On the next right.
Yeah.
Okay, because
Do a red to temp or something.
Maybe proc
Let's just read from dev MD0. How about that? DD in file equals /dev /MD0. Please redirect to /dev. No.
that works.
Redirect.
That works.
Yeah. Either one. Either one.
I'm sorry, I'm old fashioned.
I wanted to use some kernel threading.
something.
Okay. HDA timeout waiting for DMA. It's actually reading?
Okay.
Okay, it's determining now that there's a failure.
Well, now go to a third window or go to this one in the proc file system. There's an MD stat.
It's just in the timing. And it determines that the...
Yeah, it's got to wait for this to determine and take the device out of
It's
it.
going to take a long time.
You should have HD farmed it to not use DMA.
Well, we'll see what happens. All right, we'll leave it here, let it time out.
Hey, this is good advertising for SCSI.
Reboot it while rebooting and pull one of the drives.
The one that's wrong.
14 bucks. I didn't find these at the dump. I actually bought these.
The trays.
Yeah. It's not bad. It's a little plastic box. Some of the better ones are made out of aluminum. What'd you do?
Reset. Oh, it's just sitting there hanging, no telling how long it's going to hang.
We want to let it hang.
We want it to come back up and show that it can come back up.
Oh, we want to watch it reboot back.
Drive.
We did format these with the ext3, so we shouldn't have to watch FSDK run. Probably won't.
Fail. Your boot sector lost. I think
That's true. I think they're host.
So move the drive.
Okay, so move that one up.
Yeah, move the other drive.
move it into the first drive bay.
All the little things we didn't think of.
I bet you Lilo now is installed that drive.
Vios probably isn't capable of doing
Actually,
anything.
Lilo should be installed on both of the drives.
Actually, you could probably change it in the files.
Probably could have.
Okay, yeah.
Probably the easier solution.
Well,
Of course, not there.
having these little quick swap trays, actually swapping the tray was probably the quicker solution, given these files.
Okay, so our process for enterprise RAID was to contact the hardware management guy, have him walk out to the box and move the disk around. We have a process, so that's not going to slow us down.
Spare disk.
Right.
Yeah.
So it knows it's not.
Not right to the second disk.
It knows that the mirror is gone.
Yeah.
Now, let's say you get another hard drive from the dump.
There's a RAID automatic.
I moved to another town, my dump's not as good.
You can see the boot recovering journal message there, so it did recover the journal transactions that were not
Does
committed.
the RAID from the drive that is now running, will that automatically start writing?
You need RAID
second
content.
drive?
No, it's not automatic. I think there's some RAID commands. There's a RAID tool, and then you basically can do some, there's some level of automation.
Haven't played with it, but
Okay.
in one of the last couple of versions of the RAID, there is a hot swap type command that will let you tell a live running system that you have a new drive to replace a dead one, and to go use that drive and get those partitions on that drive to synchronize the good data backup.
Are these drives plugged into a RAID controller or just a regular IDE?
This is regular IDE stuff.
Plain old-
And let me make the following point.
Primary and secondary IDE
My
controllers.
entire experience is based on SCSI hardware.
Right.
We pull a disk from the SCSI environment, boom, that message pops, system just keeps right on going. I don't know what this particular hardware is doing. Maybe there's something in the BIOS I can change, or TuneFS things that I can alter, to basically prevent it from hanging when the bus gets locked.
From what I've read, it won't work at all on a regular IDE. Some of the newer motherboards actually have RAID as an addition to IDE on them, and you could deal with that.
There's the controllers you can buy that do RAID, across multiple IDE disks.
Yes.
And the way they do that is they have single IDE controllers for every disk. And these little chips cost pennies, so basically they one controller per disk, but they can stuff 10 controllers on a single card. So then you can create, low-cost IDE hardware-based RAID devices.
Right.
Yeah. But and then I think ABID or some other companies put RAID in the BIOS, so you can do a level of RAID there. But again, that's hidden from your operating system. That's all done in hardware. So I know we're running late, and I would like to invite anybody who's got to go ahead and take off. I don't want to keep you, but we're more than welcome to hang around and talk some more, answer any questions. Thanks for coming. Can you take off?
In the file system, there's an MD stack